Hello, myself Dr. Tanay Ghosh, and today we'll be learning about this different plotting, the practicals, some of the practicals with examples we will learn. Previous class, we uh, introduced what is Scilab, and with the help of Scilab, we are trying to do our calculations. So every time writing these programs on this console file is problematic. So we will start with our side notes. Here, the top left hand corner, you can launch side notes. So you can click it here. Let me show you. Side note is open. So here it is side note. So first time you open this one test file I already written to fast forward my work. I will show 10 types of practicals today. So here menu untitled will look like this, and here at first you whenever you start you clear your data first. So when you write on first command line you write clear, okay, then semicolon. You can omit semicolon here, no problem with that. Clears on the previous data. Okay. Next you type Scilab, it will clear this graphical window. Okay. Before, if you plot anything before, it will clear those. Now CNC will clear your console. So you can give this semicolon or not here. If you don't give a semicolon here, there will be no problem here. But in some commands, you need to give semicolon. So it is always a good practice to give semicolon after every command. Okay. Now after these three command, clear, Scilab, and CNC, you write your script. This is script, and then when you complete writing your script, then you save them. Here you save them. So save options have two kind of options. So one is your SC file. This is SC file, you can see test.sce. This test.sce is called script file, and there is another kind of file that is called our SCI file. SCI file is for our function file, which we will learn slowly in the next classes. So for the fast forward, I skip this part and we'll work on this previous written test SC. This is the script file here. So at first I wrote this clear, Scilab, and CNC as well. As now the first Scilab code will go for ax, y is equal to ax. Okay, first plot we will plot this. Now we already know that linspace command. So linspace have initial value, final value, and the points in between them. So I is equal to input, and this f is equal to input. This is the initial value, final value, and how many points I want. The input is another kind of command you are having here. It will ask who is running the script. This console will ask him that what value you want. Now instead of a number, we use the same namespace, but instead of a number, I put the value entered by this who is running the script. This initial value, final value, number of points he or she wants. So I don't need this one. Make it a comment. Okay. Then I need A obviously, but I also want that who is running the script, he or she enter the if I want it, that I don't know that what value you want. So I just put just ask that who is running the script, ask him or her that put the value of A in the function y is equal to ax. So this is how to write input command. Just input, then within the parenthesis, and then inverted comma, what you want to write, initial value, final value, or number of points. Okay. So So this will be written in your console. That they will ask that show. It will show in the console. This write-up which is within the inverted. Okay. Now next I want to do a plot y is equal to ax. Let it be y is equal to ax. A into A is already inputted. So A into x. X A asterisk x. Now how to do the grid will learn in the next lecture when we try to solve with the graph, plotting the graph, something to solve the equations. Now I want it as a solid line and red line with all the points as circled. So it is dash RO. We will use different kind of styles, so you will understand. So x level, in x axis it will be written x, in y axis it will be y is equal to ax. So I am putting this dollar sign, so it will look more beautiful, like a mathematical, more like a mathematical. That's why I am writing it inside the dollar sign. Y is equal to ax. That is the legend. X level, y level. Now the name. If I want to run this, at first save, execute, yes, save and execute all. You can see that save and execute all. Click here, and now show. I have to go to the console again. Here is the console. See, put the initial value. So I am putting initial value. That is, say it is minus 2 into pi. Okay. The final value is 2 into pi. Percentage pi is our fixed value, pre-assigned value. Now, number of points I take about 100, and the value of A I took negative value minus 2.03 and enter. Now everything is correct. Top right hand corner you can see all the values: A value, X value, P value, F value, and I value. All of that, and this is what I am having. Yes, this is the plot. So y is equal to X plot. See, these are all the points are circled. Okay, and this is the legend. This is the legend. Okay, this line means this is y is equal to X. It will be useful if I want to plot multiple functions in a single graphical window. But here I will show you one by one. Obviously, I will show you one example that we are plotting multiple plots. I will just give you examples. You can change the values of this A and the different graphs will come. Now let's go to our next problem. So okay, let's try another function. You can clearly see that all the points are encircled. All the points are encircled. It is solid line encircled the points. Points I have to take less number of points. in between this, and now I am taking positive inclination. Here you can see that each point is encircled here, and you can actually see what is the value of this point, x value and y value here, what is the value of x and y. Okay, this will be useful when you are trying to find out the solution. And I can also enlarge this portion. See? Here, this points, and also I can, when there is no point, I can with clicking there, I can find out the solution of that point also. I can find out the value of that point also. So we have very helpful when we are trying to find out the solution using plotting, using this plot. Now next, we will do the next practical problem, next example, that is greatest integer value, that is box x. So this all remains same, initial value, final value, and number of points all remain same, so let it be as it is. I don't need a, so I make it a comment, and then for greatest integer I put floor of x, floor x. Be very careful that whenever you open a parenthesis, always close the parenthesis. If the number of these brackets or parentheses open and close is wrong, then the program will not run. The script will not run. So I want a sort of dashed line, black color, and all points will be dotted. Okay. Now change the y level. Okay. This is for if you want to draw your x-axis and y-axis through the origin. These three comments. Okay. Then it is will have the x-axis location, y-axis location. Now this is y equal to box x. Here I put y equal to box x. Let us do this, plot the save and execute on. Initial value, minus 2, value is, let us put it as 100, and number of points, points. Let's see. Here you can see the origin shifted. The x-axis and y-axis is going through the origin. That is not very much clear, right? You cannot really observe whether it is showing the greatest integer or not. So it is better that you don't put any style for this dotted or a dash line or any solid line. Just a minute. I have to change this dash line and the limit of this initial value, final value have to change. This box function is always look like steps. This staircases, kind of staircase. I make it good. Now there will be line will be not shown, only points will be shown, and the color will be black. And let's run it. Let me show you. I am changing the points actually from initial value and final value. I will change. I will give you something like minus 2 into pi and 2 into pi, then there are points okay. Now let's see how it looks like. It will be clearly seen as step processing here. The origin, the x-axis, y-axis going to the origin, and along the y-axis it is written that y is in box x. All step functions are there, only the greatest integer value is taken. Okay. X-axis, y-axis here, and x is written somewhere. Okay, here it is the expression. Okay. It's for the y is equal to box x function. Now we'll go to our next practical class. It's practical example. In this moment, let me see. X to the power 2n. Okay, n is init, n is natural. Okay, now this all remains same, let it be. And now I want to input the value of n. Another variable I need. Input. Let the user choose the number. I can always put n is equal to some value, but here I am just giving an option that okay, you choose whatever you want. I am not giving any pre-assigned value of n. It's only run for this n value. N is equal to 2 value. You can put any value, whatever you want, and you can check. So x to the power 2 into n. Will it run? It will run, but it will show you a warning sign. Okay, so I put element wise dot because x here is a row matrix, and this. Okay. Let me type comment here. X is taken as row matrix and elements are counted vector, and n is what? N is one simple one value in a scalar quantity. That's why we have to write x element wise multiplication. You know, dot star is element wise multiplication in matrix. So similarly, dot to the power. Okay, now I done. This is a solid line, black, and they are circled. So initial value I will put minus percentage. I can write any other value also, but I am showing here this percentage pi. You can understand that we can also put this pre-assigned value also. If you have pre-assigned value, we can put it here also. N is equal to 3, and let's see how the plot looks like. See here, initial value, final value, number of points in between them is 100, and x is 1 row, 100 column. Okay, this is taken as the matrix, and this is the A is equal to 3, and this is graph, A is graph. Here it is. Sorry, I forgot to change the legend. Let me change the legend again, so it will not be confusing. I forgot to change the legend. We copy this and paste it here. X to the power 2, and you can see the suggestion is coming x to the power 2. Now I'm done. Now let's see. Again, I am doing the same. I have to give the initial value. I am giving initial value. Now I'm not giving pi something. Minus 100 to 100, 1000 points in between them, and then A is equal to something like 4, and then I plot, and here is my see. X equal to and don't know that you can see properly or not. The x equal to n is written in y-axis. Now I am removing this because every time just drawing x-axis and y-axis through the origin will be difficult. Sometimes the plot doesn't look good. Whenever you want and need this function, you have to add this. You just add this. Whenever you need your x-axis and y-axis go through there. You just add these 3 lines. Now I want to show you that if I have to plot 2 graphs in same 2 plots in the same graphical window. So I want to put this x to the power 2n and x to the power 2n minus 1. And so I have to give different names and different legend to them. So first one is solid color, black and circled. I want it to be, I want to give it a different, the dashed line and red color, and then all points will be diamond shaped. B for diamond. Another style. Now here in Y level, I change the name. Y level will be x to the power 2n minus 1. So x to the power 2n minus 1. Okay, and do the same x to the power 2n minus 1. And legend, one legend, and after that end of single inverted, again I start with an inverted and double dollar sign. Here I have to again write it inside inverted. So comma is within this end of what first inverted comma and before inverted comma, within comma. Now I save it and then run it. Let's see the graph. I think the graph will not appear very clear. Let's see. X is the initial value. We'll try and see how the graph look like. So it is, I think minus 100 to 100, the graph will not be that much clear. Okay. So first one, the black color is x to the power 2n. That graph is very much clear, but x to the power 2n minus 1, the variation cannot be shown in the single plot, but still you can see that two graphs are here. One is just the solid line circled and another is dashed line diamond. But the number of points in between these two are so many, so the line is not showing here. So I have to reduce the number of points in between them. Let me run it again. And with the initial value. So minus 2. This is plus 2. And number of points in between them is 100. N is equal to 5. Now let's see how it looks like. Okay. Yes, here it is. You can see now. This is the new plot from minus 2 to plus 2. Okay, x to the power, the red one is x to the power 2n minus 1, and this one is x to the power 2n black solid line. Okay, and legend is given here. So two plots are plotted, and the legend also shows which one is what. You can plot multiple graphs like this. I am only showing two of them here, but you can put 3, 4, 5, how many numbers you want, you can put it in one graphical plane. Okay, now let's go to our next exercise. Only okay. Let's change this. It will be 1 upon x to the power 2n minus 1. Change the name x y level. See 1 upon x to the power 2n minus 1, right? And now also the reagent. I may change the reagent and also get the title. Now anything I have to change? Okay, this formula. Yes. So x to the power 1 upon x to the power 2n minus 1. Simply put minus 2n plus 1. Right? This same. So will it be okay? Correct. Let's see. Because if it is x to the power minus, I will show you. This graph will look like this. But when 100, 6, and my plot will look like this. Here it is. So what happened here in middle portion? 0. So if x is equal to 0, you see 1 upon 0. So that's why that is showing a link, discrete point. But this you can solve it by you just after that plot you again have to write another plot x comma 0. Then you will have a point here also. That if x is equal to 0, then y is equal to 0. And for different cases, if it is sine 1 upon x, we show it. But here at x is equal to 0, there is a complete discrete. Okay, because it is not possible at x is equal to 0 you can solve it. There is a pole here at x is equal to 0. Now let's look for the next problem. That is x to the power 2n. Now I'll show you the problem. X to the power minus 2. 1 upon x to the power 12. 1 upon x to the power 12. I'll show you the problem. At first, similar fashion you write what I am writing here. This is a latex format within the $2 signs. Okay, within the $2. You don't have to learn these things. If you want to learn, you can always go to the overleaf and learn slowly in your free time. Let me show you what problem it is. 100 and give value of n, natural number. Now see, undefined variable, and this error is showing. What is the problem here? So you can check it by looking at your script file, and one by one you can just find out by putting the values. You can find out. Let me show you how we try to analyze this. So okay, this works well before in x to the power 2n minus 1 and x to the power 1 upon x to the power 2n minus 1. But here if you see properly that x to the power 2n minus 1, now in this case this is actually give you that x is a row matrix and x to the power minus 1 upon x to the power 2n give you a column kind of matrix. So that's why it is generating a problem. See, let me show you. If x is equal to this and this is y is given by x to the power this 1 upon x to the power 1 upon x to the power 2n. So this will actually a column matrix. So I will put here y, let's say y, and when I plot, so again the same problem it will show in console. Let me show you the same error will appear. See here, now it's more clear. Transposing row vector x to get comfortable dimension. Why? You see the top right hand corner. X is 1 into 100 and y is 100 into 1. That means what? Y is 100 row 1 column and x is 1 row 100 column. Okay, so that's why it cannot plot this graph. So here just simply you can solve this problem by putting y transpose, and immediately a problem will be solved in this case. So here y is a simple column matrix. One of this one is a column matrix. So that's why I am putting y dash as a transpose matrix. So x and y dash. I think you understand what is the problem we are facing. We analyzed it. Now we run. Next one. Let me show you. Run this program. Well, now I go to the console. Here I go to the console. Now I put -2. This is 2. 100 number of points between them is equal to, say I put it equal to 6. Then there is no error. You see here, no error. So y is 100 row 1 column, but y prime y transpose is 1 row 100 column. So x is 100 row 1 row 100 column is a column matrix. Y here 100 row 1 column. So I use x versus y transpose. Now if I put y, say here y is equal to y1 is equal to y transpose. Now you see here y1 is equal to 1 row 100 column, same dimension of x. Now we see the plot. Here it is 1 upon x equal to 1. Okay, nice and beautiful. Now next, let us see this problem. Next problem is square root of ax plus b, ax plus b. So function for square root is sqrt, ax plus b. So here what we need, okay, let me change the name at first of the y level. I'm doing it again, so that will not be confusing for you. I change the name as well as the title, name of y level, and legend change, y level changed, title of the plot changed. Now here I need a and b, so I uncommented this a and b, put the value of a, put the value of b, and now these all are same. Okay, fine. Now this y, this one I don't need, this y prime I don't need this one. Here I will write sqrt function ax plus b, square root of ax plus b, sqrt, then ax plus b, a into x plus b. Okay. And I also want to change the color as red or blue inside the solid line. Let me change this to okay, dot dash dot dash dot, or you can say it is solid line, or it will put, let it be a dotted line, blue color. Let me run x7 execute, and then we will put the initial value. And there is one particular case I will show you, but at first we will do the simple -3, final value is 18, and then the number of points I can put 100 points here. A is equal to something I put like it will be 18, 3 should be less than 6. Why it is less than 6, I will tell you. Okay. 3 into 2, 6. Okay. 6. Now this is your graph. You see, blue line dotted, and there is a star. Every point is denoted as star. Right. Now this is root over x plus b. What will happen if this will your imaginary number? That means it becomes a minus. If this root over x plus b become a minus, what will happen? Let me show you. Can you solve it? Where it will show? In negative, or it will show somewhere else? So again I run this program, but now carefully use something that our value will be negative. So final value points is something like point I have about 100 points, and a value I put it a high value. Let it be 8, and b is lower than this 2. So 2 into, so 8 into -2 is equal to 16. Okay, and there is b is only 2, so it will not be 0, right? So there will be a negative value, less than 0. So x plus b. So now you see plot. Though it will not show any error here, but if you see the plot here, you can see that all this -2 to from -2 to this after 0, minus 0.5, this all are in a same line, single line, because these are all points fall in your imaginary value. After that it is okay, but this range it is imaginary because root over ax plus b is becoming negative. Is imaginary. Ax plus b become negative. Root over ax plus b become imaginary. So be careful about that. We can solve this problem using our loop. Okay, but for the simplicity first, that example we are not using those kind of things. Initially bottom position, we are not using this. Next we will understand. Our next problem is mod of ax plus b. Absolute value. It is 1. Change the value here. Change the value. So here. And now just put ABS. ABS for absolute. Okay. Then now I show another style. I'm showing you different styles. So you should remember it is dot slash. Yes, dot dash. Dot dash, and points will be square. Denoted by square. Square blocks. Let us put the initial value. Minus 10. Final value is 15. Number of points, let us take it as 20 points in between them, and A is 2, B is some value 6. Negative value I can also put there, and yes, so here is a dot of mod of ax plus b. Okay. So one will be in positive value, y is positive, whatever x is negative or not, y will be also mod of ax plus b will be always positive. Now next function is c plus or minus ax plus b. What we do? C plus or minus sign here. Now again I need this value of c, so I will unput this, uncomment this, and here I put c plus. Program is complete. Now here I can change another, that is blue and magenta color. And this is D, diamond. Here I run again. Change here C plus title. Now let us run. We will go to the console. Put the initial value. This is the console. $20, $30, $50, and number of Let's take less than difference. A is to B is something is 8. Okay, 3 values, A, B, C values are taken. Now let us see how the plot look like. Here is C plus ax plus b. Now you can also draw C minus ax plus b. Changing the values, you can have different plots. Actually, you have to plot multiple functions in a single graphical window and then set those graphs to compare. I already show you that how the multiple plots can be put in there. Questions will be given like this, that C value, A value and B value will be given for different A1, B1, C1 value will be given, and there will be fx1, fx2, fx3, 3 functions or 4 functions. Now next is signum x, which is your mod x by x. Action mod x upon x. Mod x upon x. Previous one. Copy. Here. Previous one. Mod x plus x. Mod x plus x. So mod x plus x. Signum, this mod x plus x is called signum of x. I don't need A value, I don't need B value, I don't need C value. And here, I put, write down the function here. It is signum, S-I-G-N of x. That means mod x by x. I run this program. Save and execute. Put the console, put the values, and this is your plot. Magenta color. Mod x upon x. This is for x when x is negative. For x is negative, the lower value, and all because this is 1 plus 1, and when x is negative, that will be minus 1. Now let's go to the next function. Sine of this. Be careful. This is the while you plotting this graph, it will create a problem. I will show you how to solve this problem. You simply put this graph wrong. It will plot a graph, but that is really wrong. Okay. Sine 1 upon x. Now in this case, x is a row matrix. Okay, x will be given as a row matrix. Okay, let me at first, every time putting this initial value, final value, points, the entire sum. I did it for you, so you will be very much familiar with this. But now I am just taking a fixed value from minus 2 pi to 2 pi. Okay. So I don't have to input every time. Now, if I directly put that here, that will create the same problem, you understand? That the X is row matrix, so Y, that the X to the power 1 upon X will be a column matrix, and obviously they will not match in dimension. So here we put Y is equal to 1 upon X. That is the last time we saw it like that. Y is here is a column matrix. We did what? X and Y, then transpose this. So sin Y, will it give you answer? No. It will not give you a desired plot. Let me show you. Is it 1 upon sin X? Is it a sine curve? Does it look like a sine curve? This is a straight line. This is not your desired plot. So where is the problem? Where is the problem? What do you think? Think about it. What problem we are having here? Think about what happens if X is equal to 0. So if X is equal to 0, 1 upon X is something unknown. 1 by 0 is like infinity, approximately. Though it is undefined, we cannot really find out the value of 1 upon X. This should be the graph. How we can have this? Okay. It is already told you why this is happening. Now, let me show you what you have to do. Input. So this is the real graph, and just wait a second. Now what you have to do? Input a value a is equal to minus 1. Now, instead of putting sine 1 upon X, you put here X to the power a. So this means X to the power minus 1, that is 1 upon X. Fine. And now this is red color. And next I know that sine of 1 upon X at X is equal to 0. It is like sine, it will have a value 0. Right. So again, I overplotted. Two plots will be there. So one plot is this previous first plot, X comma sine X to the power minus X to the power a, which is this one, and then X and 0. There is a single point. There is a completely single point. Okay, that will be in that color or blue color, whatever it wants. I am not putting any color sign or any style for it. Y means our function, not fx. That's sine sine of 1 upon x. Okay, so let Let me show you the graph. Okay. This is the plot of sine 1 upon x. Okay. So the single point that x comma 0, that plot x comma 0 is not that much visible in this plot, but that is present here. So be very careful when doing this, particularly sine 1 upon x. Now, almost programs are shown. Let's show you last couple of programs. I think this program, if I write this script, that will cover almost your problems. Almost all of your problems will be shown. And others, whatever graph is there, plotting is there, you can do it from this exercise. With the help of this exercise, very easily you can solve this. Next is dot star x into sine 1 upon x. X is x into sine 1 upon x. X into sine 1 upon x. You can see. Now next I write 1 upon x, 1 upon x, it's 1 upon x, fine. So in this case, what I do, a is equal to sine x I put. Okay. Now I write x into a. A into dot divided x. The dot is because what? This because x is a taken as a matrix, row matrix, and A is also a matrix. So I am doing element wise matrix multiplication. Element wise matrix multiplication. Not doing matrix division. I am doing element wise matrix division. Element wise. Okay, this is not the graph. Okay, show this one. Yes. This is how it looks like. Because of that limit I have taken, it is not that much clear. Let me show you more clearly. It is from minus 2 pi to 2 pi limit. It will be not that much visible. Let me take in this range a little bit more extensive, minus 50 to say 50, and I am taking 1500 points. Okay, now let me run this. If I execute, run the script, yes. So this is your 1 upon x sin x. 1 upon x sin x. Don't look at the legend and y axis. You already know how to change that. So I think you are almost all practicals problem, floating problem is solved. In the next class we will understand two the problems, different problems, solving the problems with the help of Scilab plotting. Last plot I show you that e to the power ax plus b, that is exponential of ax plus b. So in this case I am taken here, I do, and with the value of a and b, pre-assigned value. So this I commented, fine. Plot. Now this is not needed anymore. And now we put exponential. Exponential function is exp. Okay. Exp is for the exponential value. So exp within that parenthesis we write ax plus b. That will be exponential ax plus b. Okay. And now you run, and I show you. Here is the plot. It will be for ax plus b. Okay. So this is the end of my second lecture. It is quite a very big lecture, I understand, but there are so many practicals have been shown here. So go through it. Take your time one by one. You write down those script and run it by yourself. This is almost 20, more than 10 plots have been shown here. So take care and stay healthy.